This is the beginning of module 4. It's going to be graphing and applications. We're going to look at equations and inequalities in two variables to begin with. So until now, we've done everything mostly algebraically. We saw that solutions to equations and inequalities in one variables could be represented on a number line as either points on number line or intervals. So for example, when we solved absolute value equations, we wrote them as 3x minus 2 is either 3 or negative 3, solved it for x, and ended up with x equals 5/3 or x equals negative 1/3. These two solutions can be represented graphically on a number line, on a real number line, as follows. And you already know how to do this, so this is just a quick review. So if I label this tick mark as 0, then this is 1/3, 2/3, 3/3, 4/3, 5/3. This is negative 1/3. And so negative 1/3 and 5/3 are your solutions. So now the question is, we know how to plot these real numbers on a number line as we just showed here. And one question to ask is, how can we visualize equations and inequalities in 2 variables or even 3 variables for that matter? To answer that question, we have to get familiar with the rectangular or Cartesian coordinate system in 2 and 3 dimensional spaces. So let's take a look. In the rectangular coordinate system, instead of having just one number line, you're going to have to work with 2 number lines perpendicular to each other. They are called the axis. The horizontal axis is called the x-axis, and the vertical line is called the y-axis. The point where the 2 axes meet is referred to as the origin and is labeled as coordinates 0, 0. In general, though, the coordinates are labeled as ordered pairs where the first letter x represents horizontal distance that you are moving from 0, 0, and the y coordinate represents vertical distance you are moving from the y coordinate. X, y variables represent that this is a generic point, can be anywhere in this plane here. And so if you take a particular example, let's say you go 6 horizontally and you go 2 vertically. Then what do you think that coordinate should be labeled as? First coordinate is the x, second is the y. So 6, 2 ordered pair represents this point here. And you can see how we are ordered here. Depending on where you are, we'll change the coordinates. But always x coordinates comes first, y coordinate comes second. If you want to refer to points that are generic and they don't have specific coordinates, mathematicians have developed a way to do that by just simply saying x sub 1, x coordinate of the first point, y sub 1, y coordinate of the first point, second point will be x sub 2, x coordinate of the second point, y sub 2, y coordinate of the second point. So the subscripts allow us to generate more variables because there's only 26 letters in the alphabet, so we may run out of points if you have more than 26 points. And so this is a clever way to represent generic points, which you'll see a little bit later that will make use of it. But either way, you are representing the x coordinate is how far you went horizontally from 0, 0. Y coordinate is how far vertically you went from 0, 0. All right, so let's do more examples so that you become familiar with how to orient yourself in this coordinate plane and how to represent these points. For many of you, this will be a review. So here we have 0, 0, and again, if I go 6 over and this much up, what do you think the coordinates will be here? Well, that would be 6, 3, because you've gone 6 just like we did before, but instead of 2, I've gone 3 up. All right, let's take this coordinate. What do you think that will be? Pause the video and see what you can write this as. All right, let's just do a whole bunch of points. How about that one? Because it's not on any particular tick mark, you're just going to have to estimate where it is. So we're 3.5 from 0 sideways and 2.5 up from the 0, 0 in the y direction. How about that point here? This point here, you're going to have to go to the left first and then up. So that would be -6. So when you go to the left, you have negative numbers. When you go to the right, you have positive numbers for x coordinate. When you go up, you get positive numbers for y. When you go down, you get negative numbers for y. So you can see how we're just going to go through and label a few points and see if you can understand why the coordinates are labeled the way they are. So you get the sense of what's going on, right? So once you know how to work with these points, oh, what happens if the point lies on the axis? Well, you've only gone 8 over on the x-axis from 0, 0. You're not going any direction in the y, so you're going to have to label the y coordinate as 0 because you didn't have any vertical movement. So what about, so that would be -4, 0. How about that one? You want to try that one on your own? Yeah, good. So that would become 0, 4, and that would become x coordinate will be 0, y coordinate is -3. So this allows you to plot points and be oriented in the two-dimensional space here. All right, so now when you know how to plot these coordinates, you can see how the whole space, the two-dimensional plane, is divided into 4 parts. When both x and y coordinates are positive, this is called quadrant 1. When x is negative but y is still positive, you're in quadrant 2. When both x and y are negative, you're in quadrant 3. And when x is negative, and then when you are here, x is positive, y is negative, and that will be the 4th quadrant. All right, so now that you know how to work with that, why don't you do some of these video log questions? All right, so how about now we're giving you the coordinates and you draw your coordinate axis and appropriate scale to figure out how you're going to represent these coordinates onto the rectangular coordinate system. You're going to have to draw each coordinate axis separate, one for one coordinate axis here, one here, one here, one here, one here. So you'll have 5 sets of x and y axis so that you can choose appropriate scales to mark these points. Be as accurate as you can be by choosing the right scale. So an extension of the two-dimensional space would be to three-dimensional Cartesian coordinate system. What do you think that involves? Remember, we started with real number line. Then in two-dimensional, we had 2 number lines perpendicular to each other. So now we're going to have what? 3 perpendicular lines called the axis. Often the x-axis is pointing towards you. The y-axis will be going left and right, and the z-axis will be going up and down. Again, where all the 3 axes meet, the points are labeled as 0, 0, 0, and then the rest of the points are based from this origin point, the reference point, and you go x direction first, y direction second, and z direction last. All right, let's see if we can visualize this. Again, if you can't really see the three-dimensional aspects of it, let's just put a little box around it so you can actually see. So this is the x-axis coming towards you. This is the y-axis going sideways, and the z-axis is going up and down. And again, you can see the orange plane is the xy plane, the green plane, which goes through the x-axis, and the z, it's in up and down in the z direction. So this is the xz plane. And the blue plane, which you see sideways here, is the YZ plane because it goes in the Y direction and Z direction. So 3 intersecting planes tells you how you are broken now into quadrants instead of quadrants, which we had before in two-dimensional space, into octants. You have 1 here, 2, 3, 4, and equivalent 4 here, behind on this side, and on the front bottom here. So those are the 8 octants they're called. Don't worry too much about this. We really are just trying to show you how you can keep extending to even 4 dimensions, 5 dimensions, just have to keep adding more coordinates. It's harder to visualize the 4 and higher dimensions though. Okay, so here is the 0, 0, 0. I'm going to draw a box because otherwise it's harder for people to see how we're moving. So if I move in the x direction first, then instead of 0 for my x coordinate, I'm going to have a coordinate. So let's say I move 2 units on x-axis. Let's say I move now sideways in the y direction. So let's say I moved 3 units over. So then the y coordinate became 3. And then if I move up, then that's going to change the z coordinate. Let's say z was 5. So if you imagine this box in the corner here, this corner of this box is where you're moved to. If it's not making too much sense, don't worry about it. But it is important to see how things extend from one to another to another. And again, if you want first point, second point, you just have to add subscripts